6.5 today, multiplying polynomials. We're going to multiply monomials times other polynomials, not considered monomials. And then we're also going to multiply binomials times each other. Okay, so when we're multiplying monomials, in the first ones I see here that we do practice, we do multiply a monomial times another monomial or monomials. We're going to just drop the parentheses because the parentheses right now are just whenever we have parentheses around something next to something else with parentheses, those back-to-back parentheses mean multiplication. So there's really a invisible multiplication symbol in there, and so we can just drop our parentheses because there's no addition or subtraction. That's why we can drop them, okay? So you really make sure that you're not just saying, oh, she said if we have back-to-back parentheses, we could just drop them. No. I said back-to-back parentheses mean that there's multiplication going on. If there's no addition or subtraction, we can drop parentheses and insert multiplication symbols, like I say right here. Then we can rearrange the factors. What property allows us to do that in multiplication? Rearrange the factors. Jacob?
Associative.
Associative is kind of like yes in a way. We can kind of group them in whatever way we want. That's what associative does, is let you group in whatever way you want. Jared? Commutative property of multiplication allows us to have them trade places. So when we rearrange, we're really having them trade places. That's the commutative property. And then the associative property says, okay, you can put these together in a group and multiply them, these together in a group and multiply them. Okay? So when we are going to take, number 1, 3x squared times 6x, is there any addition or subtraction going on there? No, none whatsoever. So we can just ditch those parentheses and say, really, we can just insert a whole bunch of multiplication symbols here. We have 3 times x squared in the first monomial. That monomial is going to get multiplied times the other monomial, which is 6 times x. So it's just straight multiplication all the way across. In polynomial, monomial answers, what comes first, the constants or the variables? The constants. So we just rearrange it so that it will end up with the constants being first. So now we're just applying the commutative property. And now the associative property really says, okay, these guys can be multiplied times each other. Those guys can be grouped together. What is 3 times 6? 18. And x squared times x.
X cubed.
X cubed. Remember when we learned multiplying powers, we add their exponents. This has an invisible 1 on it. 2 plus 1 is 3. So our product is 18x cubed. Okay, you go ahead and multiply number 2, and let's see if we all get the same answer. Show those steps, please. And do you end up with the same thing I do? 10a to the 5th. Okay. Anybody have questions? How about in this next one, number 3? What would, if once I start rearranging it, I'm just going to do the drop the parentheses thing right now and write down all the multiplications. What's that negative sign going to become? Negative 1. We're going to make that a negative 1. So this right here became our negative 1. So a negative sign in multiplication can always become a negative 1. It's been cleaned up. That's what it was. And then we will rearrange it so that we have all of our constant terms at the beginning. Which factors would we line up next? X's, Y's, or Z's? X's, because remember, algebra likes alphabetical order. And next would be the Y's. And last would be our Z's. That's always a really good idea to count up how many did you have in the line before, so you make sure you still have that many after you rearrange them. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9. After I rearrange them, I still have 3 there, 4, 5, 6, 7, 8, 9. Still have 9. Okay, multiply that out and see what it becomes. See if you agree with me, or do you need to challenge me? Do I need to change my answer? What do you feel? X squared times x cubed, 2 plus 3, 5. Y times y to the 4th. Y is y to the 1st. 1 plus 4, 5. Z squared times z to the 5th. 2 plus 5, 7. A third of 12 is 4, and 4 times a negative 1 is negative 4, right? Okay. So monomials times monomials. Any problem with those at all? Okay. Then multiplying a polynomial by a monomial, in other words, when the polynomial is not a monomial, then we're going to have to do distributive property, and then just multiply our monomials. So let's show how many multiplications will there actually be to get rid of this addition? How many multiplications will there really be to get rid of this addition? That's to get rid of the parentheses, I should say, not the addition. 2. We're going to take 3ab times 5a. There's one of our multiplications right there. Plus, we bring down our plus sign from our parentheses because we're doing distributive property right now. And then we have our 3ab times that b. So there's our other multiplication. And now we have monomial times monomial plus another monomial times a monomial. So 3 times 5 times a times b. In our notes, we want to be this complete. We want to be able to see where did we get that from. So now I'm just doing the rearrange, add in multiplication signs. 3 times 5, the a's come before the b's. So what's the first monomial multiplication become? What's this one? 15. I can't hear you. A squared b plus. What's the second multiplication become? 3ab squared. Okay? How are you feeling about that? Are those like terms? Can they be combined?
No.
Why not?
They have different exponents.
They have different exponents. A squared b's are not the same as ab squares. So we can't combine those. That we'd have to say this is our final answer. That's as good as it's going to get. Okay. So distributive property. Okay, let's go to the back side then. I think you probably have another one to do. Go ahead and do that one, but I suggest you, what do you suppose I'm going to suggest you do first? Change the subtraction inside the trinomial to add the opposite first. And then you will set yourself up for better success. So not do anything but change this. In fact, I might even slip a 1 in there. And then do your distributive property. Again, showing good, complete work because it will be more helpful when you look at your notes later. So negative 2y gets multiplied by all three terms of the second polynomial. We have three multiplications actually going on. We should end up with a trinomial answer. Rearranging, adding multiplication symbols, what happens next? Still have three multiplications going on. And then I also want you to decide what kind of a polynomial answer do we get. You can name that. I want you to classify it right under your notes. I want you to classify it. What kind of polynomial answer is that? First, let's also decide if you agree with me. Okay, first of all, do we agree that the product is negative 6y cubed plus 2y squared plus negative 8y? I guess I have not cleaned it up. I better clean it up yet. And show how would it be shown in an answer bank? There's the way to be shown in an answer bank. Minus 8y. Do we agree on that? Yeah? Okay. What kind of a polynomial do we have? Cubic, trinomial. Why is it cubic? Third degree. It's degree 3. And why is it trinomial? 3 terms. Okay, so we have a cubic trinomial. So again, it's important that we still can identify these polynomials that we are working with. So a cubic trinomial. Okay. So any questions on monomials times monomials? Or monomials times other polynomials? Binomials, trinomials, four-thirds, whatever. Okay, then we're going to multiply binomials times each other. They show a method here called FOIL. Tell me, what does FOIL stand for? What does FOIL stand for, Ed?
First terms, outer terms, inner terms, last terms.
Yeah, F for first terms, O for outer terms, I for inner terms, and L for last terms. First terms of what? Of the binomials. Outer, meaning there's four terms altogether, aren't there? Outer means those outside ones. Inner means the two inside ones, and last means the last of the what? Binomials, yeah. Now this is not the only way to multiply binomials. There's also other ways. You could do rectangular multiplication, rectangular array multiplication. But here's something that you must keep in mind. FOIL cannot be used for any other type of multiplication except binomials times binomial. Why? Wouldn't work otherwise. There's how many letters in FOIL? 4. How many terms are there altogether when we have two binomials? 4. Yeah. So it only works for a binomial times a binomial. You cannot use it on any other type of multiplication. So first thing I'm going to do is always change any subtraction to add the opposite, always. Because trust me, you will make less mistakes getting the right answer in the end. You will have to clean up an answer in the end probably, but that's okay. And then set up your FOIL. I can't remember exactly how the book does it. Is this kind of what they do? Something like that? Or is that kind of how you did it in your SV3Rs? So in other words, just set up the multiplications that are going to go on. And then what happens between all of those letters? What do we actually do with all of those multiplications? We add them, don't we? Yeah, so we make it into an addition problem. So what's the F step going to look like in this one? A times A, the first times the first. And that becomes A squared. The O step, A times -4, the outer ones, the ones that are on the outside of the lineup. And that becomes -4A. What's the I step? 3 times A, and that becomes 3A. And what's the L step? 3 times -4. And 3 times -4 is -12. Okay. Now what we do is we just move all those pieces down and they become an addition problem. So we have A squared plus -4A plus 3A plus -12. Typically, when there's one variable only involved, and that variable is to the same power in both of them, typically what should happen is these two terms, the O and the I step, should be like terms. They should be able to be combined. So A squared doesn't have anything to be combined with. What's -4A plus 3A? -1A, and then that -12 doesn't have anything to be combined with. So we can combine the -4A and the 3A. And then now we'll clean this up. What would this look like in an answer bank? How would this look? Jared?
A squared minus A plus 12.
Yeah, here's how it would look in an answer bank. A squared minus A minus 12. Okay, FOIL is really an important thing to make sure that you understand how it operates, because we're going to eventually do what's called take it from the product state, A squared minus A minus 12, we're going to take it back to the binomials state. We're going to undo the multiplication. We're going to say, where did that come from in the first place? And that's a really, really huge skill that if we don't know how to multiply and, as I call it, unmultiply, factor it, it's going to be really tough to do a lot of the other math classes that you have left to do. Okay, anybody got questions on that foiling that we just did? Okay, what's going to happen in number 7? Can we do this? Can we give that exponent to each of those, do you think? What do you think? Think so? That would work? What is x squared? That's x squared, right? What is 3 squared?
It's 9.
That's 9. So here's what would happen. We'd end up with x squared minus 9, right? So you feeling pretty good about that? That it's that easy? Let's see what really happens when we do FOIL, okay? What does x minus 3, that binomial, with a squared outside of it, really mean?
It's x minus 3 times x minus.
Yeah, that means take x minus 3 times its self. That's what it means. So the red right now, that's kind of on hold. We're seeing, are we going to get that answer? Can we take that shortcut, in other words? So right now, we're not sure if we can take that shortcut that's there in the red. We're going to FOIL this and find out, let's see, after we change it to add the opposite. We are anyway. So we're going to have x plus a -3 times x plus a -3, and now we're ready to set up our FOIL. Okay, so go ahead and FOIL this out and see what you get when you FOIL it out. Did you get the trinomial x squared minus 6x plus 9? That's the same as x squared minus 9? No. Be really careful. You cannot take some shortcuts that you're really tempted to take. We learned, back when we were doing powers, when we were doing exponents, we learned that you can give, if you have a product to a power, you can give each factor that power, that exponent. We did not learn that if you have a difference, a subtraction problem, or a sum, an addition problem to a power, you can give each of the terms that power. We never learned. There was never a property like that. So we cannot do this one up here. This is a no-no. Don't even try to take that shortcut. You will not get the right answer, ever, by taking that shortcut. Okay? So anybody got any questions? Okay, then go to work.